This chapter closes out Phase 3, and it answers one of the most common interview questions there is. Walk me through what happens when a client connects to the database. If you can tell that story cleanly, you look like someone who's set up connections 100 times. And the centerpiece of the whole story is one process, the listener, the front door to the database. We'll meet the listener, see how services fit in, learn the two ways a client supplies connection details, and then assemble the complete connection story you can recite on demand. By the end, that classic question won't rattle you at all. Let's meet the listener. It's a separate process running on the database server whose entire job is to wait for incoming connection requests from clients. Here's the sequence. A client wants to connect, so it contacts the listener. The listener checks which database service the client asked for, and it hands the connection off to a server process inside the instance. And here's the elegant part. After that handoff, the client talks to its server process directly, and the listener steps out of the way and goes back to waiting for the next request. The mental image that makes this stick is a receptionist. They greet a visitor, direct them to the right office, and then they're immediately free for the next visitor. The listener doesn't stay in the conversation. It just makes the introduction. How do you configure and control the listener? It's configured in a file called listener.ora, and you manage it from the operating system with a utility called lsnrctl, listener control. The command you'll run most is lsnrctl status, and it's genuinely one of the most useful diagnostic commands you'll learn. It shows you the listener's alias, what port it's listening on, almost always 1521, and, crucially, a summary of the services registered with it. Look at that services summary in the output. It tells you which databases are actually reachable through this listener. And lsnrctl start and lsnrctl stop do exactly what they say. So listener.ora to configure, lsnrctl to control, and lsnrctl status as your go-to when a client says, I can't connect. That's often the very first thing you'd check. Now, what exactly does a client ask the listener for? A service. A database registers one or more services with the listener, and the service name is what the client actually requests when it connects. This matters enormously in multi-tenant from Chapter 2. Each PDB presents itself as its own service. So the service name is precisely how a client reaches a specific pluggable database instead of the root container. If you want to connect to the sales PDB, you ask for the sales service, the HR PDB, the HR service. That's the routing mechanism. So don't think of connecting to the database in the abstract. Think of asking for a named service and the listener directing you to whatever database backs that service. And how do those services get registered? Automatically, which is the next nice detail. Here's a detail that shows you understand modern Oracle. The instance registers its services with the listener automatically through a feature called dynamic service registration, handled by a background process. In the old days, you had to manually list every service in listener.ora, which was tedious and easy to get wrong. Now the instance essentially announces itself. Hi listener, here are the services I offer. That's why, on a modern system, you usually don't hand edit service entries at all. They show up on their own. So if someone asks how services end up known to the listener, the answer is dynamic service registration by a background process. And it's also why, right after you start a database, you might run lsnrctl status and watch its service appear a few moments later once registration completes. So what does a client actually need in hand to connect? 3 pieces of information: the host, the server's address, the port, usually 1521, and the service name, which database it wants. That's it. Host, port, service. Everything about client connectivity is just supplying those 3 things. And there are 2 common ways to supply them, which is the next distinction interviewers like. One method writes them directly into the connection string and needs no configuration file at all. The other stores them under a friendly alias so you can connect with a short name. Both get the same 3 facts to the client, They just differ in whether you type them out or look them up. Let's compare the two, because knowing both and when to use each is a clean thing to be able to say. 2 methods. The Easy Connect method puts the 3 pieces directly in the connect string, in the form host:/port/service name. It needs no configuration files at all, which makes it perfect for quick connections in labs. You just type it and go. The tnsnames method instead stores those details under a named alias in a file called tnsnames.ora, so the client can connect using a short alias, say salesd, instead of the full host, port, and service every time. Look at the 2 commands. The first spells everything out with Easy Connect. The second just says it's salesdeb, because the details are looked up in tnsnames.ora. So Easy Connect for speed and no setup, tnsnames for reusable named connections. And there's one modern enhancement worth a mention. Quick modern detail that signals you're current on 19C. Easy Connect used to be pretty bare bones, just the one host, port, and service. In 19C, it got enhanced, and you'll sometimes hear it called Easy Connect Plus. The enhanced version can accept multiple hosts for failover and additional connections settings right there in the string without needing a tnsnames file. You don't need to memorize the full syntax. Just knowing that Easy Connect was extended in 19C to handle more than the basics is the kind of small, current detail that makes an interviewer think, this person actually keeps up. Drop it in when connection strings come up and move on. Now let's assemble everything into the full story, which is the answer to that opening question. Here it is, the full connection story, the answer to that opening question, in one flow. Step 1. The client resolves the host, port, and service name, either from an Easy Connect string or from tnsnames.ora. Step 2. It reaches the listener on that host and port. Step 3. The listener matches the requested service and spawns or assigns a server process for the session. Step 4. The listener steps out of the way. And Step 5. The client and its server process communicate directly for the rest of the session. That's the whole thing, and notice how it ties straight back to the request flow from Chapter 1, Client, Listener, Server Process Instance. If you can walk through those 5 steps smoothly, you've nailed one of the most common interview questions there is. Practice it until it flows. Let's prove it from both sides. From the operating system, lsnrctl status shows you the listener and every service registered with it. That's your front door view. Then, from inside the database, $session shows you who's actually connected right now, the username, the program they're using, the machine they came from. Filtering on type equals user hides the background processes, so you just see real user sessions. Put those together, and you can trace a connection end to end. The service is registered with the listener, and the resulting session shows up in $session. When someone reports a connection problem, this pair is your diagnostic combo. Is the service registered, and did the session actually land? These views return in Chapter 17. Let's lock it in. The listener is the front door. It takes connection requests, hands them off to a server process, then steps aside so client and server talk directly. It's configured in listener.ora and controlled with lsnrctl, status, start, stop. Clients ask for a service name, each PDB is its own service, and registration happens dynamically. To connect, a client needs 3 things, host, port, and service, supplied by Easy Connect or tnsnames. And be ready to recite the full story. Resolve, reach the listener, match the service, and assign a server process. Then direct communication. That completes Phase 3. Now we enter Phase 4, protection, the heart of a senior interview, and the chapter that genuinely gets people hired, backup and recovery with ARM-AN. That's Chapter 14, and it's the big one.